Thank you. So, welcome everyone to How a Ruby Profiler Works, Stackprof under a microscope. So, my name is Ivo Anjo, and I was actually born in Setúbal, which, if you don't know where it is, it's like right there. It's like 1 hour away from Lisbon at the mouth of the Sado River. If you do get the chance to visit Setúbal, I do recommend very much trying the local delicacy, choco frito, or fried cuttlefish, which has this whole cool story because it's actually not local, but come talk to me after if you're curious. I actually started working with Ruby here in Portugal when I joined a company named Talkdesk around 11 years ago, and I really started loving Ruby, and I kept on doing Ruby. So nowadays, I work as a staff software engineer at Datadog, and I work on the Datadog Ruby profiler because I really enjoy this work of looking at our applications in different ways, building cool visualizations to look at applications to understand better how they work. If you've not heard, if you're in the half of the people that didn't raise their hand, and you don't know my employer, Datadog, we do modern monitoring and security as a service. So for Ruby, we have a lot of things, not just profiling, but distributed tracing, test optimization, security, errors, logs, etc. So here's a pretty screenshot showing a bunch of metrics, a bunch of endpoints in an application, as well as the flow of requests between a bunch of microservices. Here's a screenshot of the product I work on, the profiler, and this is showing the flame graph, showing like where the CPU is being used on this application. And this is another pretty screenshot from a visualization we call the thread timeline view, where for each thread in your Ruby app, and from left to right, we show like a long time what's going on in each thread, so you can really zoom in. Yeah. And thanks for Datadog, my employer, for sponsoring this trip. So we're here today actually to talk about a different profiler, a very cool profiler named Stackprof. So what is a Stackprof? Stackprof is a Ruby profiler gem that's been created by Aman Karmani back in 2013. And nowadays is maintained by Aaron Patterson, and there's a lot of work from the community to improve on it. So why did I pick Stackprof to talk to you about today? So why is Stackprof interesting? The Stackprof is interesting because of a few things. One is that it's a low-overhead Ruby profiler, and being low-overhead is quite important because if you add a profiler to your application and your application slows down, then the things you learn from the profiler don't really match what you see in production, so you really want a profiler that doesn't really change how your application behaves. It can profile CPU time, wall time, object allocations, and a bunch more things. And if you're not sure about the difference between CPU and wall and whatnot, I will explain it a bit, put a pin on that. It has a lot of different output formats, including my favorite, which are flamegraphs. And it was actually the inspiration for the Datadog Ruby profiler, as well as Vernier, PF2, and is used by Rack Mini profiler. So I studied Stackprof very closely to learn, like, OK, how do you profile Ruby? What are the things you should do? And it was a really big inspiration. And there's a big thing that I find very interesting about Stackprof, which is that all of this is done in less than 2,000 lines of code. If you look at the Stackprof folder, you'll find that there's like around 1,000 lines of C code where most of the magic happens. You have 700 lines of Ruby code just to create like different output formats, so convert from the internal format to like a gazillion format. And that's it. Like that's less than, oops, just give me 1 second. Obviously, there would be technical issues. And that's it. Like that's less than 2,000 lines of code in total. And that's all you need to know. So Stackprof is both a great profiler as well as a great way to learn how profilers work, which I find really interesting. So before we go deeper, let's address the S word, which I'll be using a bit in this presentation. The S word is sampling. And the idea with sampling is that it's a technique that's used by low-overhead profilers, such as Stackprof. And the idea is that instead of trying to record everything that happens in an application, like in full detail, you kind of replace it by doing something more periodically, by periodically checking. And one clear example of this is that, like, instead of counting every time you call into each method call, maybe just check what Ruby is doing every 10 milliseconds, or even every 1 millisecond. And the advantage here is that if you do this, you usually don't, you don't have the count of, oh, this function was called 10,000 times. But if the profiler tells you, oh, 70% of your CPU was in on this function, that usually gets you in most of the information you wanted to know. And the trade-off you make here is that it's much faster. So if you try to count every function call, that's kind of expensive to do it very, very accurately. And if you do this sampling technique, you kind of have a lever where you can lower the overhead. And for instance, you can sample for a longer time if you want to have more data. So you can kind of have more control over the impact on your application. And Stackprof uses sampling, so that's why it's so important. So I actually, because Stackprof is so small, I'm going to put all of the Stackprof C code in the slides. The idea is not for us to understand all of it. It's kind of to see, one, it's very small, and we can see the main 4 components of a profiler. So here's the first slide, and if you kind of squint at it, there's you start by, okay, there's some setup, there's some helpers for the time, like current timestamp, something like that, difference between what was the previous sample, how much time, more setup code, and then we find the state. So the state is, if Stackprof was written in Ruby, this would be all of the instance variables, all of the configuration. And then we find some more setup code, and then we find the first big component from Stackprof, which is the code that decides when to sample. So this is a big part of a profiler. When do you sample? What's the trigger for sampling? Then, if you scroll down a bit, we'll find the second big component, which is the code to format the results. And you will notice that things seems to be out of order in the Stackprof source code. I'm not sure exactly why, but yeah, the code to format results comes after the code to decide when to sample. And then after that, there's some more code for setup. And then you will find the third big component, which is the code for storing a sample. So when you take a sample, you want to store a sample. Then, scrolling down a bit more, there's some bit more for storing a sample. And you'll find the final big component, which is taking a sample. That's it. And then after that, there's some code to make sure that Stackprof plays well with the Ruby garbage collector. There's some code to make sure that Stackprof plays well with child processes. And then I actually lied. It's not 3 slides. It's 3 and a bit. But the rest is just random C code that you need to do when you have a Ruby C extension. And that's kind of it. You saw all of the Stackprof C source code in 3 and a bit slides. So I find that really amazing that a really nice profiler, it actually fits in the slides. And so we saw the 4 main components. They are when to sample, taking a sample, storing a sample, formatting the results, and a bunch of C boilerplate that we don't care about. C is kind of verbose, and if you were writing in Ruby, you wouldn't need to do that. So let's look a bit deeper into each component to understand how a profiler works. So the first part is when to sample. So I said that one of the modes that you can run Stackprof in is object allocation. So the idea of the object allocations is that you create a trace point. If you ever used the trace point in class in Ruby, it's basically a class that allows you to observe events in Ruby applications. But we're actually using with a special event, which is the Ruby internal event new object. And if you look at the trace point class documentation, you will not find this event, because this event is only available when you write from C code. But otherwise, it's very simple. So you basically give Ruby a function, a C function, and you say, Ruby, whenever you create a new object, call our function with this object so we can do things with it. So that's how we sample object allocations in Stackprof. The other one is CPU and wall time. And this actually works a bit different. So for this one, Stackprof is using one thing called the interval timer operating system API, which is like a Unix or Linux API. And the idea is that we ask the operating system to periodically emit a signal using this function, the setItimer function, which is somewhere in there. It's at the bottom. And then we actually provide a function to handle the signal handler using a function named SIGAction. For reasons, there's kind of 2 separate functions. So you use one function to ask the OS, can you send me a signal? And you use another function to say, when I get the signal, call this function, please. But it's kind of like the two things. And the idea is that if you see the code supports both wall time as well as CPU time. And if you want wall time, we ask for the iTimer real, and we'll get the SIG alarm signal. And if we want CPU time, we ask for the iTimer prof, and we get the SIG prof signal. And I will explain a bit what's the difference here. But it's actually interesting to know that like SIG prof is actually a built-in feature on Unix and Linux for profilers to use. It's kind of cool that the OS is already giving us some tools to do profiling. So let's do a sidebar and talk about what I mean about CPU time and wall time. So the key difference is that CPU is the actual time your application spends running on the CPU, spends using CPU. Whereas wall time is the time that passes in the real world. It's like if you're looking at Big Ben, you see the clock hands move. So that's the big difference. And so for instance, if I have a sleep in my application, or if I'm doing some database call, then my CPU does not need, it does not spend CPU. My CPU could be even doing anything else. So this means that we get 0 CPU time, even though in the real world, if you do a sleep or if your database call takes 2 seconds, you actually do observe it. Your customer is waiting 2 seconds for the web page to load. Whereas if you do something like in the bottom, where you take the current time, you add 2, and then you kind of ask Ruby to loop and constantly ask the operating system, what's the time, what's the time, what's the time, what's the time, until it's the correct time, then you will burn 2 seconds of CPU time, and as well as 2 seconds of wall time. So that's kind of the contrast between them. And in applications, you actually usually care about both. They are both useful when you're trying to optimize an application. Because obviously, if you want to improve the efficiency and the performance of your application, you might want to care about CPU time. But wall time is more about the latency. How much time even if your application is not on CPU, maybe it does 10 database calls, and those database calls are slow, so your customer is waiting for it. So it's quite important to know about the wall time, as well as like troubleshooting and planning the capacity of the system. How many threads do you run your Puma worker with, and things like that. So both are important to observe different facets of how your application behaves. Okay, so let's go back to the when to sample. We know that we ask the OS to emit a signal for the CPU and wall time, and then this function would get called. And when Ruby creates new objects, the function on the bottom gets called. So what now? What's the next step? Now we get into the code for taking a sample. So taking a sample, it's actually like, let's look into the Stackprof signal handler. And again, don't try too much to read the code, just kind of squint at it. And if you squint at it, you will see safety checks at the top. Then there's some code to handle multiple threads. And actually, this is a bit of a limitation in Stackprof, is that it's kind of limited if you have many threads in your application. But come talk to me afterward. I don't have a lot of time to cover this today. Then there's more safety checks, and then we get to the interesting part. The interesting part is Stackprof checks. Is Ruby doing a garbage collection? If so, Stackprof takes like a garbage collection sample, and it basically calls this function, Stackprof job record GC. It calls it in a weird way using something called the postponed API, and I will explain it a bit, but what you need to know is like it calls the record GC function. If Ruby is not doing GC, then this is a regular sample. So what Stackprof will do is it will call this Stackprof buffer sample function, and then it will call job record buffer using the postponed API as well. So it's not a lot, and hopefully you're not very lost yet. So let's look at what buffer sample does. If we look at buffer sample is quite simple. It does 2 things. One thing is it records the current timestamp, so what time is it now? And then it uses this API called RB profile frames to get the backtrace for the current thread. So this is similar to when you get an exception. You see, foo called bar, called method, called this, called that. So basically, it gets this information and puts it in a temporary place so that we can show you later where your application was running. So that's it. That's it. All, like, how many lines of that? Like 20 lines of code? That's all that's needed. For the garbage collection, it's a bit more code, but if you look at it, what it's doing is, it takes a timestamp, and instead of taking the backtrace, it basically writes just a string garbage collection, and then checks, oh, is Ruby doing marking or is Ruby doing sweeping, and then adds a string with that. It's a lot of code because C is very verbose, but you would do this in 3 lines of Ruby code if you could do this in Ruby code. But it's kind of hard to do a profiler for Ruby in Ruby, so you kind of need to do it in C right now, nowadays. So sidebar, why are we doing this whole like postpone thing? And why are we separating the taking the sample with actually storing the sample? The reason is that this is needed for correctness. The operating system signals that we're using can trigger at any time. And any time here is really any time. They can actually interrupt system calls, so you might be in the middle of calling into Linux, the operating system, to do something, and this might interrupt that thing, and actually the Ruby VM does a lot of work to make sure that like Ruby will, oh, this was interrupted, I should repeat it, etc. So this is fine, but there's a lot of work done inside Ruby to make sure that this is fine. And they can also trigger at very inconvenient times. If you've ever used C, you might be trying to allocate memory in C, and but if you do it inside a signal handler, it might happen that you're doing allocating memory in the middle of allocating memory, and that's a really bad idea. And you might be in the middle of, again, garbage collection, or Ruby might be dealing with some locks, or you might be creating or destroying threads. And the problem here is, like, because this is really anywhere, your application might not be ready to look at this information. The thread might be invalid because it's just about to die, or the thread might be invalid because Ruby is still kind of creating the thread. Creating the thread is not 1 line, it's 10 lines. So if you catch it, Ruby in the middle, you can find like a confusing in-between state. So because of this, there's actually a name for the functions that are safe to be called in this, like when you are handling a signal, which is called async signal safe functions. And the like things that are very common in C code, like malloc to get like memory, printf to print or puts. You can also have puts in C, or most Ruby VM APIs that you might want to use are not safe to be used in this situation. So what happens is that Ruby has this API called the postpone jobs API, which is a sync signal safe and kind of creates a bridge to solve this problem. And so the idea of this API is that these postpone job APIs will mean that like Ruby, you will say to Ruby, Ruby, please get me to a safe point, and then call this function with what I want to do. And the way this works is that like a safe point, and I put it in quotes because Ruby does not actually call it a safe point, but this term comes from like the Java community, Go, and a few more other languages call this exact concept a safe point. And the idea is that when Ruby calls your function, it guarantees that you have like the global VM lock, and that you are not in the middle of garbage collection, and that you can now call into any API, fine, you will not cause the application to crash. And you can even call into Ruby code another VM function. So basically, it's kind of a way to delay, it's kind of a callback kind of thing where you say, Ruby, when it's safe, call me back, please. And then Ruby is like, okay, now it's safe, I will call you back. So that's why we separate taking and storing a sample. Okay, for the new objects, for sampling new objects, it's kind of similar to the signal handler. So we actually do one test where Stackprof counts how many objects you've allocated. And this is how Stackprof does sampling of objects. So instead of sampling every object, it might say, oh, I sample every 100 objects or every 1,000 objects. So this means that you still get all of the information you need, but you don't get as much impact on the application. Then we call sample and record. Then instead sample and record, we call again buffer sample, which is the same thing we saw before, which takes the stack trace. And then it calls record buffer. And in this case, we don't need the postpone thing because the trace point API in Ruby works differently. We only need that for the operating system signals. With me so far? Let's look at how we store a sample. So the storing a sample, it has a bit more code, but if you just kind of squint, at the top you have some memory. C needs to create space to store this information. So again, this would not be safe to do from inside the signal handler, so that's why we need to do the separation. Then there's two ways of storing data. One which Stackprof calls the raw samples, and then another one which Stackprof calls aggregate samples. And it's quite simple. The idea is that the raw samples basically keeps two arrays where we put the backtrace in the array. So maybe we had method foo, which was calling into var. And if this is the first time we're seeing this, we put in there a 1. And then in the other way, we just put the timestamp when we saw this. And that's it. This is how we represent one sample. And then on the next sample, if we still see the same stack trace, we remove the 1 and we put the 2. We saw this 2 times. And then we add the new time that we saw this. OK, the time has advanced. And then every time we're putting information on this array, we check, is it still the same backtrace? If it is, we increment that number. If it's not, we put 1 to the aside. Maybe now it's a method called hello Euruko. And then we add the timestamp and so on and so forth. Of interest, we only put from left to right. So we don't go back. So if the same stack trace would appear again, foo and bar, we would add it again. We would not go back and increment that number because that's kind of costly. So the aggregate data format is kind of very similar. So the idea is that it doesn't store the timestamps. So we know, OK, we saw this method 20 times, but not if it was 20 times in a row, or if it was 1 at the beginning and then 9 at the end. And it actually, because we don't need the timestamps, then we do simplify, we do the compaction of the backtraces. And so it means less repetition, which means less memory use. So all of the tricks here are about making sure you have as little impact as possible on the application, but still get very valuable data that you can use to debug what's going on in your application to improve performance and solve issues. And that's it. The final part is formatting the results. So formatting the results is where we take something like that. And Stackprof actually supports many formats. One format I like to use when I'm doing experiments is the stack collapse format. And stack collapse works as simple as it's a text file, and each line has a backtrace and how many times that was seen. So for instance, if we take that example I put in there and I showed before, we create a file with we had foo called into var, and we saw it twice, and then we saw a call to hello Euruko. It's as simple as you take this file, and then you go on the speedscope.app website, you drop this file there, and boom, you already have a visualization. You're already seeing your data as a flame graph. And now you can dig into what's happening in your application. So this format is really cool when you're doing simple experiments. And if you've not seen a flame graph before, here's a few tips for the flame graph. From left to right, it's usually not time. Flame graphs have a cousin called flame charts, and flame charts use time from left to right. But the, let's call OG flame graphs don't do left to right time. So left to right might be something as alphabetical ordering or some kind of sorting, but it's not time. So that's quite important to keep in mind. From top to bottom is method calls. So you see, we actually see there the foo. What? I was trying to get my laser pointer to work, but no. OK, we see that foo calls into var, and we see that separately we have hello Euruko. And the width of a column is how much or how often the profiler saw it. And so the really cool thing about the flame graph visualization is that naturally it draws your eyes to the correct thing. Because if something is really small, then you maybe don't want to care about that. You want to care about the thing that's really wide. So it kind of naturally, like the big things kind of scream at you, hello, I'm big, please fix me. You can probably make your app faster. And that's it. So wrapping up, I think that Stackprof is a really cool profiler, a really cool tool, and a really cool thing to experiment with. I also think that figuring out what's going on in your app and doing this kind of visualizations is really cool, as well as Ruby is amazing because it gives us all of these abilities to do this. And flame graphs are really cool. And I may be biased in my thinking that everything is cool. In more serious matter, the sampling is a very important thing when you're kind of doing this low overhead profiling. It's this interesting trade-off. If we could record everything, we would, but recording everything changes how the application and makes it really slow. So you really want to record the important things in a really strategic way. Unix and Linux signals are really weird and are this really obscure part of operating systems that it's kind of interesting about. You often, when you're doing this kind of tool, you might want to separate the buffering the data from actually recording it. And this RB profile frames function and the postpone job APIs are the magic behind many Ruby profilers. So if you look at the Stackprof, the Stackprof profiler, or you look at the Datadog Ruby profiler, you will see like lots of code around it, but at its core, it will be a bunch of RB profile frames and postpone jobs. And it's kind of cool how the same idea works. You just have to change the way you trigger. Maybe you trigger on wall time, maybe you trigger on how much CPU time you spend, maybe you trigger on allocations, etc. And this gives you many different ways of analyzing your application. And that's it. I'm really curious to see what bugs and performance issues you will fix in your application using a profiler. I'm also very interesting to see more people experimenting with profilers. That's why I wanted to give this talk, to show you like it's not that hard. It's 1,000 lines. Yes, it's C code. C is kind of boring and scary, but it's not that much. You can get into it. You can experiment. You can change one bit and see what it does. And yeah, I want to see what profilers will you build. And that's it. Thank you.